Yeah.
I'm sorry, are we supposed to be following on the
Yeah.
here though? I only got to the part where I didn't get to the details of the right hand side. I don't think anyone has really well.
Nobody can get internet?
No, we get to it, but I can get to that page there.
Yeah.
I guess.
You didn't.
Yeah.
I don't see anybody else getting it. That can do it.
Ah, você já passou da página do Ricardo? É aqui, aí vai fazer alguma coisa aqui.
Então, mas aí.
Are you gonna type something
Então,
on
mas
step
aí.
2? Are you gonna type something somewhere?
I'm just going to click on define project area.
Where?
Yeah, we did.
Oh, define project area. Okay.
Okay, accept, certo?
É que ele ainda não fez essa parte, você já vai na frente dele.
Ah, já foi.
Ele ainda não fez, ele vai fazer. Okay, he was ahead. I'm sorry, he was ahead.
Okay. Well, my one seems to block access.
Close the navigator. I think it's
Close the navigator, I guess.
Before copy the
close the link from
but before copy the
What do you use then? You use Explorer?
No, you can go back to the same navigator.
maybe just above.
Sorry, the mistake with my services. Sorry.
It's
Okay.
on project. He is asking for translating the.
Accept. And now you choose an area. So let me just go to USP. That allows you to actually define the area itself. Now, this is a much bigger area than I do because remember, we're going to have 100 points. So obviously the greater the density of points, the more precise the results. But if I was to digitize the area, I might do something like this. So all I did was digitize the zone. Now, I'd suggest you pick an area of maybe only about 1 square kilometre. So pick out an area that you're familiar with. Might be a suburban area. I know if I was to do this in Dublin, for example, some parts of Dublin are very, very well vegetated, but some parts are completely barren. Finish.
I'm sorry. After you made it polygon,
Yeah.
Polygon. What did you press?
Finish. Down at the end there.
Finish. Oh, here. Thank you.
Now, you did the same area as me, but I would choose an area you're familiar with. This is a very, very big area, it's very, very green. Choose an area like a neighborhood that you know,
Okay.
that you'd say, okay, it'd be interesting to see if one street's better than another. So once you define your study area, it allows you then to configure your survey. So this is the default, which is that it's just a tree or not a tree. But in fact, I can add any class I want in there. For example, I could add a class which says So I can add another class if I want. Like say, for example, I could describe one as a
After finish, what do I do?
then I went into configuration.
Ah, here. Okay.
And now it allows you to configure. In other words, when it gives you a dot, it allows you to ask, how do you want to classify that dot? So now you think about the nature of the urban landscape and what type of information you want. So if you look at the moment, the configuration just has two things in there, tree and non-tree. So you could delete not tree and replace it. In this case here, I've added one. I put the plus here and I added paved.
Paved, okay.
And I added the plus there and I put in building.
Okay.
I'll do one of them and just put in effectively grass or ground cover. And finally, I'll put down something like other things that I can't recognize. That means any particular dot that provides me with, I have to classify it either as a tree, as paved, building, grass, or other. So the way I would normally do this in the class at home would be if I had a big class of GIS students, and about 40 or 50 in it, I'd ask them to all start digitizing. And then I'd accumulate all the data so I get all the information about the city. So it'll make my life easier. So they're the ones I've chosen. So let's say I was happy with that. I say next. This is what I mean by it's American. Now they've started to change. They've started to change a lot of the information. So for example, the reason why they want the selected locations here is because they feel that they have all the information on air quality in this part of the world. Now I know that iTree themselves have started to incorporate different tree species of South America and of Europe, so they're getting better and better at making them more generally useful. So I'm going to skip over this. You can see here are all the different types of pollutants I can remove, including carbon dioxide. And I say begin survey.
You don't press anything.
Sorry?
You let this thing the way it is and
Yeah.
you go begin survey.
Yeah.
Okay.
So there's the area. I'm just going to get rid of all those symbols on there.
How do I erase the old area that I had marked? Because now I have two, this one and this one.
I don't know.
Okay.
Let's see, when you actually add it, see now, the first thing up here, everything's empty.
Uh-huh.
There's trees, there's paving, there's building, there's grass, there's other. As soon as I press plus there, it gives me a spot. Okay? So that's the roof of a building. So I classify as building. And add another dot.
I can choose another place because mine went to the old area that I made at the polygon.
I think the only way out of that would be to actually start again and erase the old one.
Okay.
But I mean, all we're doing is demonstrating a principle here, so we're doing much more.
Okay.
So that's obviously a road, so identified as a road. page, sorry. There's a tree canopy. There's a tree canopy. There's a tree canopy. There's a tree canopy. It's a very green part of the road. That's a building top. At the top of the building. So in essence, all you're doing is sampling the landscape to provide yourself with some idea about the land cover.
That percentage that it shows,
Yep.
it shows based on the samples or the entire year.
No, based on sample. So every time you punch a number, all numbers change. But at the moment, they're very, very few. So for example, it's calculated trees at 55.6, but the standard error, the error associated with taking a sample, is huge. So it says that the real percentage is somewhere between 55.6 minus 24.8, or 55.6 plus 24.8, and that I'm 68% sure that's the true value. The more points I take, the bigger the sample size, the more precise my results. So essentially, I keep on doing it until I get out my cover. When I'm completed, it will give me information about the nature of the air pollution that's capable of taking on the atmosphere.
How many samples would be?
Well, I'll tell you what I did. I'll show you some examples that I did in Dublin that I found very effective. I talk about in a 1 kilometer radius, I took about 1,000. And the reason I did that was because I wanted to introduce maths from the last
You can export this something KNZ or something.
What you want to do is, you have to be careful about this because the way it stores the information, if you move it at all, it's impossible to find. So you have to locate where it stores the file, but you can export it and export as XY coordinates and then the value. So what I'll get out is I'll get out the XY locations of every single point, and whether it's T, P, D, G. But essentially it's a sample information.
Não, mas ele escolhe o consultório aleatoriamente.
Okay, I've done 50 points so far. You can see we're getting a lot more precise. So now it's down to 42%, but there's 7% error. So if I keep on going, what happens is that number gets lower and lower. My evaluation of the amount of canopy cover in the area gets better and better. And I get the percentages out also. I don't know if you've done a lot of tree research or tree digitizing. It is extremely hard to do. I know from experience because we digitized all the trees in Dublin, and it's taken us a couple of years to do it. Because what the satellites can do is they can pick out green, but it's extremely difficult to pick out a tree from grass, and it's extremely difficult to pick out a tree from shadow. So digitizing the individual trees takes an awful long time. This I found is one of the most effective ways I can convince people in planning of the value of trees. Despite the fact that a lot of it's based upon American data, everybody intuitively understands information that we get. Let me just give you a few examples showing you how I use this data myself. Like all cities, mostly they're paved or they're built upon. That's the definition of a city. Green space is often extremely valuable. This, for example, is a green space in the middle of the city. It's one that everybody gets sent to because it's very, very important. And there's a big competition to make sure it's as beautiful as possible. It's got trees, but you can see the surrounding landscape has got very, very little green space. Now, one of the arguments made about why we should green cities is that it is inherently good because it creates a little bit of rural environment inside the city. Anybody who lives nearby can get access to it. But it's also argued that the green space provides facilities that extend beyond the boundary into the surrounding area. Now, in our case, this was a central park in the middle of the city. And we do things like I take leaves from the trees along the edges here. And you can wash off the leaves and find out what the materials are on those leaves. So, for example, there's a big traffic light here. There's a traffic light here. Here's a light rail system. There's a traffic light here. But not surprisingly, all the leaves here, here, and here are covered with materials. But the leaves over here are very, very little because the traffic is very light there because that's where the light rail system is. Now, so that means that the park and the boundary serves a very important function. It protects the interior from the exterior. So many people would see the park as like a refuge in the city, a place where you get seclusion and separation from the outer environment. Now, there's a price to be paid. If I can stop stuff coming into the park, it's also true about airflow and movement outside the park. In other words, the consequence is largely the microclimate of the park is largely contained within the park itself. It does not extend out. So when people say, oh, we need to have green spaces because the green spaces here will help to air conditioning in this area here, that's not true. The effects of the park are largely confined to the park itself and just a little bit with it. So our study was about trying to figure out about green spaces in Dublin where there was green places and not green places. Now it's a very difficult thing to do, as I said. I'll just show you some examples. This is my city. These are the types of greening that you can see in different places. Well, actually, you can see that. You can see that around South Paulo, green walls. That's largely by chance, by the way. Green channels. This is a way by which they convert paving to make it green. So you can see the individual bricks there, but allow them to grow grass on it. These are considered quite effective, except you can't really make a road out of this. You can make a car park space out of it, but they don't have the strength to support lots of vehicles. And then, of course, the thing that everybody's happy about, these things called green roofs. I'm less sure that they give a lot of value, I'm afraid. And here's the thing about trees. With the root system, if they're completely connected to the soil, which means they break apart the ceiling of the landscape. The root system allows it to channel the water up, and then the water is actually released into the atmosphere by the leaves through the stomata. But the stomata don't just give out water vapor. When they're actively breathing, they also take carbon dioxide and they take out any other particles that are present in the atmosphere. So they'll also take nitrogen oxides and sulfur dioxides. The leaf of the tree itself, depending on its type, will also capture and store and become encrusted with particulate matter. So the leaves act as like a big filter inside the city. They regulate. In other words, if there's a drought, the guard cells will close the stomata and they're no longer engaged with the atmosphere. Then you lose out on all those other functions. So the trees work best, obviously, if they're healthy and well watered and looked after. Trees in the city have a hard life, particularly if they're next to streets. As a consequence, that means that their functions are often limited. They often have very, very short lifespans. So here's all the things that iTree allows you to assess. iTree cannot be just the simplest task and focuses only on air quality. That's what I mean by a poor old tree gets a haircut every morning. When these buses go by, just shaves it. Yeah. Their infrastructure. That means they have to be treated like infrastructure. If I walk around the streets of Sao Paulo, they do heave up all the bricks. I'd say this is a hard city to be in a wheelchair in because the road paths are very, very uneven, and the effect of the trees is simply lift up the paving. But I think you have to see them as infrastructure in the city as a whole, in which case they have to be maintained. Here's an example of how they do work. This is an instrument we had in Dublin. Up here is that measures radiation. There's another instrument up here that measures carbon dioxide in the atmosphere. So what I plotted out here are, on a typical day, cars. Right? This is traffic. Thousands of cars on the street. All the cars generate nitrogen oxide, they generate the sulfur dioxide if they have diesel, but they also generate carbon dioxide. And all that stuff goes into the atmosphere. And then the atmosphere can wash it out. But here's the thing about trees. If the trees are growing, they take in the carbon dioxide. So for example, this is during the summer months, the trees are all growing. Look what happens. As soon as the trees are active, they start to consume the carbon dioxide in the atmosphere. So here they are during the middle of the day, and they're most active. They're engaging, they're photosynthesizing, and they're taking carbon dioxide. And at the height of the traffic emissions from the cars, that's when the trees are doing the most work. Here's the thing, you'll never be able to plant enough trees to take carbon dioxide out of the air, I'm afraid. Every car produces about, well, if it's a nice new car, it it uses 140 grams of carbon dioxide, grams of carbon for every kilometre travelled. So if I look on the streets, say Sao Paulo, thousands upon thousands of tons of carbon are being pumped into the atmosphere. Trees can only take out a small sliver of those. So, the methodology you're using there was the first methodology I used to try and figure out tree canopy cover across the city. What I did was I divided up the city. There's the city, there's the county of Dublin. And I randomly sampled across the entire landscape. I identified it, whether it was a tree, whether it was paved, whether it was grass, etc. So what it showed me is a clear pattern. You notice why do I have big squares out here? Well, because this part of the world is not really occupied. Everywhere where I have small squares, that's where the city is. So here you can see the city. It's impermeable for the most part. And that means there's also a deficit of trees. And there's also a deficit of trees up here. That's because this area here is used for agriculture. And it's a strange thing. You'll often find more trees in cities than you find in rural areas, especially if the rural areas are used for growing crops. They don't have trees. The city centre has no trees, but in some parts of the city have lots of trees. And I used that methodology you did there to try and assess for each of those places. This is Dublin city centre. These are the other parts of Dublin. Carbon monoxide, nitrogen oxides, ozone, sulfur dioxide, PMs, and all the rest taken out by the trees of Dublin. It shows that Dublin city, CO2 sequestered 13,000 tons over the course of the year. The amount in storage, 215,000 tons of storage. I'm obviously a human geographer. I can tell you that if you talk about trees in cities and talk about planting trees in cities, it suddenly becomes politics. And my city, like any other city, if you were talking about planting trees, a lot of people would get very, very angry. They'll also get angry if you start taking away trees. Nevertheless, the judgment about where to put a tree is a very, very political one. So don't forget that. That means that when you make a statement as a physical geographer about changing the city to meet some sort of requirement, you're going to have a lot of politics involved in why they shouldn't do it or why they should do it. But this is a very, very effective way of making the physical geography case, because the trees themselves do a lot of the work to compensate for the bad effects in the city. So, for example, in my case, working for Dublin City, they want to know, as is typical, are we better or worse than any other city? So what we did was we did an international comparison between Dublin and other cities around Europe, because that's the only ones they cared about. So here's the percent tree canopy in each of those cities. So you can see Helsinki, Finland is 49%, Vienna, Austria, just 4.9%. But of course, this is largely based on how you define the city. If you define a city to limitate certain areas, you can always change the percentages. Why does it matter? Here's me plotting out tree canopy cover across the city. This part of the city is quite green. This part of the city, you can see, is very, very few trees. The city centre is very few trees. Not dividing line there, the dividing line between wealth and poverty in the city of Dublin. In other words, wherever you get trees, that's where you get the big houses, that's where you get the big gardens, and that's where you get the trees. Whenever you get poor areas, you don't get those things. If I take how much the houses go for, these are the property prices in 2015, you can see all the green ones, the highest prices are all the areas that are nice and leafy. All the lowest prices for properties are all located in the areas that are. And I used that methodology to try and compare the different cities. What I did was, one of the problems associated with geography is there is no natural boundary. So I put the center of a circle in the middle of the city, drew a 1 kilometre boundary around it, and then assessed using that 1 kilometre radius around the city centre, how many trees are inside the area. So I took the points, the XY coordinates out of that, and I plotted out the locations of them. And I plotted out the locations of the green area. So you can see in the city centre of Dublin, in this case here, it's practically a rock. There's very, very few places available for trees, that there are trees inside the city centre. And here's a comparison then based upon that consistent measure. By choosing a 1 kilometre radius, I get around the problem of comparing like with like, and now I can just compare circles of exactly the same size based on the city centre. So now you can see that Copenhagen, let's say, are generally green, that other cities are far less green. Belfast, which is the north of Ireland, is notoriously barren. I was going to call the title paper Belfast is a stone. I think part of the reason is because Belfast was at war for about 30 or 40 years, so they got rid of all the trees. So the only trees that existed in Belfast were the parks. Now here's the thing. It means then that you can actually start to look at what is the capacity for greening the space. So for example, in Dublin City, there's the percentage of tree canopy, there's the shrubs, there's the grass. So obviously I can increase canopy cover by increasing the amount of tree cover. There's the impervious, so I could take away part of the impervious. That's the capacity for actually converting green rooftops. Just 1/5 of the land area consists of rooftops. Just to give an example then. So probably have to go up there. Oh, I'm sorry, I lost it. So I found that particular piece of software an extremely effective way of evaluating neighborhoods. So, for example, if you went from different neighborhood to neighborhood across South Hall, as far as I can see from the space, some of those neighborhoods are extremely green and some of those neighborhoods are completely barren. So, for example, if I was looking at the favela, which is just outside University of Sao Paulo, I can't see a single tree in that entire area. I'm not sure many people live in that area, but I can't see one single tree. There are other areas where there are big boulevards and there's very few trees, and other areas where it seems like the entire street is completely covered by the canopy. That particular piece of software I think is an extremely effective way of demonstrating the value of green infrastructure across the city. I don't know what you think about it. It is a sample, but within a matter of a few minutes, you were able to assess an area in terms of the capacity of that system for doing air quality. What do you think about it? If you go into the other tools, you'll see that it's possible for you to put in actual species of trees. And different species of trees have different capacities. Some species of trees are evergreen, which means they operate throughout the year. Others are deciduous, which means that they generate lots of litter. And they only provide these functions for part of the year. Very simple. And they're always interested in hearing about people in other countries, particularly if they can tell them about tree species. So that means they're very open to having discussions about developing the technique. As you'll see, if I go back,
Do you want to start over?
if you go back to the home, you can see that all the different the translation automatically. it allows you to do various types of planning with regard to trees. So it's not just about assessing what's there, but also allows you to intervene and actually say what types of trees you might want. And all I can say is, in terms of our experiences with the group in North America, we went back to them repeatedly with the tree species that we'd collected from Dublin, and they're prepared to adjust or find matching tree species in North America that could tell us about how they perform in our environment. So I find it a very, very effective way of evaluating the green infrastructure in the city and its capacity to provide some form of cleansing, to offset the things you don't want about the urban environment. We should be able to, I think that should be. I know I can open this, I've done it before. It can be the individual XY location and the property of this family. Okay, that's it. This is a relatively simple one. I'm hoping that next week I'll be using QGIS and using the 3D building height stuff to look at things like shadow patterns. I was trying to incorporate weather data, but I have to say I find it next to impossible to find weather data, hourly weather data for Sao Paulo. Does anybody have any hourly weather data for a period of time in Sao Paulo? If you just send me even a month's worth or a year's worth of data, I'll incorporate it into the UMAP model and show you that it's capable of actually producing more than shadow pattern, but it can also tell you something about the temperature. So if you just email it to me at gerald.mills@ucd.ie, I'll get it. Okay, Sinead, thank you.